Now, the idea of atoms is a very old one. You can find people writing about this in ancient India and ancient Greece, and there were many different ideas about what atoms might be like. I'm going to focus on just one person in the ancient world. Around 400 BC, there was Democritus, and they called him the laughing philosopher. A lot of his work was burned in the Middle Ages, but his idea about atoms survived. He said, look, there's an experiment you can do. Take an apple, okay, and then cut it in half. Now, each half is still apple. Cut each half in half. Well, each half of a half is still an apple. But how long can you go on doing that and still have something that is recognizably an apple? You're going to get down, he said, to a point where you can't cut anymore. You will get down to a particle that is uncuttable if you divide this enough. And the word for uncuttable in that language is atomos, or atoms, and you can see where atoms came from. They are uncuttable little particles that you will eventually come down to. Now, later on, Aristotle came along, and he said, no, you can keep cutting forever. There is no uncuttable little particle in there. It turned out in the end that Democritus was right about this and Aristotle was wrong. But Aristotle's ideas held sway because he was such an excellent speaker, an excellent thinker. He was a great philosopher, and everybody took his word. And there was no further progress on atomic theory for 2,300 years because of that. Let's go back to Democritus's idea. Democritus said, well, water is made out of little water atoms. He didn't know that they were actually molecules. He thought they were atoms. And he said water flows really nicely because because the little atoms are very smooth. They're like little ball bearings or marbles. When you dump a bucket of marbles or a bucket of ball bearings, it looks kind of like a liquid flowing. So he said the properties of the material, properties like fluidity of water, come from the properties of their atoms. This is a kind of a big idea, and it is something that we still have. Some of the properties of the elements come from the properties of their atoms. Now, he said when one thing is more dense than another, then it means that there is more space between the atoms in the less dense thing. For example, here's water. If you have ice, and I'm drawing the water molecules the way he did, not the way that they actually are. If you have ice, the atoms arrange themselves, the molecules of water arrange themselves in a certain way, and we've seen this already, to make open hexagons, and there's a lot of space in here. So this has more space in it than water. This is less dense than water. So it explains why ice floats on water. So it's not just the properties of the atoms, but there are arrangements that can determine properties like density. And that also is a good idea that we've kept. The arrangement of atoms determines the density of the material. So we can explain why some materials are more dense than others with Democritus's idea here. Now, here's something else we can do. Water flows, so its molecules, he said, were smooth and slippery. What about iron? Iron does not flow. got to get it very hot to do that. Imagine iron atoms as being little picky balls, burrs, like those burrs that you see growing by the side of the road that get into your dog's fur when you're running your dog. Now, these things, because they are picky, will kind of catch on each other. And when you try to press iron, you may be able to press them down, but they'll stay stuck to each other. And this explains why you can take a metal and hammer on it, hammer it out into a sheet. So, all in all, it wasn't a bad idea. Now, what was wrong with it? Well, there was no way to test these ideas. So we had hypotheses here, but we had no way to test them. We had no way to connect the atoms that Democritus had to actual real observations. We couldn't propose a hypothesis and then disprove it using experimental operations, experimental measurements. So that means it was a philosophy. If you've got a hypothesis and it's not testable, you're saying, I propose this, and then you build a logical structure on top of that, that's philosophy. Science requires that you do a reality check on it. We'll see the next incarnation of atomic theory that came, that was 2,300 years later, really gave atoms a property that would allow you to test hypotheses like this.